Okay, this week the topic of the lecture is pre-registration, which I covered a little bit last week when we were discussing questionable research practices, and I mentioned that pre-registration is one of the most powerful tools for preventing questionable research practices and also just demonstrating that you have engaged in rigorous research methods. Just to give you an idea of the kind of things you're going to be learning about today, I want to make sure that you are familiar with the remaining two questionable research practices. I presented these last week, but I didn't go into any detail. The reason is that both of these, the Garden of Walking Paths, which sounds cool, right? Basically, it means research effectability, and HARKing, which is hypothesizing after the results are known. Are really quite closely tied to pre-registration. Pre-registration helps to fix these two issues in particular. So make sure that by the end of today you're able to discuss these two, you're able to describe what these two refer to and their negative implications that they have on our understanding of the world around us. Then we'll be discussing what pre-registration actually is. In particular, we'll be discussing two different types of pre-registration. Broadly speaking, unreviewed and reviewed. You should pay specific attention to the reviewed version because for your assignment during week 10, you are going to be writing essentially a reviewed, what's known as a stage 1 registered report. In fact, you're going to be doing a stage 1 registered replication report. And then today we'll be finishing with a discussion on what the benefits of pre-registration are. And also I want to make sure that you're familiar with some of the limitations associated with pre-registration. This slide from last week should look familiar to you. We outlined the traditional publishing model, or the traditional science process of science that starts with thinking about a study and ends up with a paper getting published. And we discussed the limitations of this traditional model, namely that they allowed for questionable research practices, and then I ran through a series of those questionable research practices, including not reporting measures, dropping studies, excluding participants, and running extra participants. So just to jog your memory, we discussed a study that was investigating how coffee affects student performance. So half the students were given no coffee, half the students were given coffee. It seemed a reasonable study. They reported one measure: how alert has a student been during a class. They were asked to self-report that on a 1 to 7 scale, and then the study concluded that there was a significant and positive effect of coffee in student performance. I won't go through all the examples, but if you recall, we demonstrated how it would be possible for such a simple study on the face of it to actually be manipulated. So for example, say had the study been conducted 5 different times and only one of them was significant, a researcher that only prioritizes getting publications and doesn't prioritize presenting an accurate image of reality or an accurate portrayal of the data that he's obtained could just publish that one study that found a significant effect and not publish the others. In fact, we discussed this in terms of the file draw problem. And this is a really big problem affecting psychology, and it's something that lots of research methodologists and open science advocates are really trying hard to combat. And the registered report format of pre-registration attempts to do so. And we'll discuss how when we get to it. Another thing you could do is not report conditions. So let's say that Professor Starbucks, who conducted the study, had a third condition where he had participants drink water, but it found that when he compared coffee to water, it didn't make his product, his coffee, look good. That coffee was no better than water. Why would Neil, the lecturer, pay someone to give students coffee if he can just get water for free? Now, one of the questions you should ask yourself when thinking, both when you yourself get data and you ask yourself, what is the thing to do now? You should try and figure out what's best interest for you, what's in the best interest for you, and what's in the best interest for science. What's in the best interest for science is that Professor Starbucks publish all the conditions that he recruited, so that we know coffee's better than nothing, but equal to water. What's in the best interest for Professor Starbucks is to just drop the water condition and publish the coffee condition compared to no. Okay, the purpose of open science, or what open science advocates are trying to do, and what research methodologists today in psychology are trying to do, is try to get our incentives, the researchers' incentives, to align with what's good for science. And remember, what's good for science is to try and have an accurate portrayal of the scientific process, so what happened between the researcher thinking of the study design and the researcher publishing the study, and also having as much of that data available as possible. Today, as I say, we're going to be focusing on these two questionable research practices, garden of fork and paths, which essentially the garden of fork and paths isn't a questionable research practice as such, but exploring, walking down the garden of fork and paths is a questionable research practice. And then we'll be discussing HARKing, hypothesizing after the results are known, which again we'll get to. Just make sure that when you familiarize yourself with these QRPs, you also understand why they're problematic, what impact they have on our understanding of the world. Okay, so if you're a non-scientist, you might think that science is objective, that you come up with a theory, from that theory you derive predictions, and then you go out and collect data, and that data wholeheartedly, resolutely, 100% clarifies whether or not your theory was supported or not via its predictions. In truth, that's just not the case. When we have a raw data set, so let's say I've completed a study, I've collected all the data, and that data is just sitting there. There are so many decisions to be made about that data set. So for example, if with the Professor Starbucks example, there are three outcome variables. I could decide to investigate all three. I could decide to just investigate one. Professor Starbucks decided just to investigate the self-reported measure of alertness. He then, if you recall back to last week, decided to compare coffee versus nothing. And he then employed a series of exclusion criteria. He looked at people who liked coffee, who enjoyed the course, and who didn't feel anxious. Notice he could have gone down any one of the other pathways. He could have looked at participants that didn't like coffee, that didn't enjoy the course, or that didn't feel anxious. Or he could have looked at people that didn't like coffee and did enjoy the course. So I hope you see in this way there's all these different pathways that are being crafted out and are possible to walk through when you get a data set. And then if you recall, he ended up looking at, after making those exclusions, he then compared the coffee group to the no coffee group. And that is the t-test that he reported. Now, this is one of many, many studies, tests that he could have performed. He could have chosen to look at coffee versus no water, and he probably did. If he's willing to engage in these practices, he probably did take a look at coffee versus water, probably looked at the different exclusion criteria, and ended up comparing coffee versus water. Maybe it wasn't and it was non-significant, so he decided not to publish that. He just dropped the condition. Okay, the point that you should be taken away from this is that even though science tries to be objective, there are many, many subjective and many reasonable decisions that all could be justified when you're analyzing your data. It might be perfectly justifiable to exclude participants that didn't enjoy the course or don't like coffee. The question is, by having that possibility, or the point is, by having that possibility there, you are creating a whole world, many different analyses that you could perform, and then you're only reporting the ones that happen to be significant. Now, if the data set generally showed nothing's going on, remember, sometimes, just by chance alone, we'll get significant findings. The fact that we get these significant findings doesn't mean that they exist in the real world. They could just be a random act of chance that exists in our data set. So we shouldn't be extrapolating from our data set to the real world, especially if we didn't predict it. Okay, so this could just be something idiosyncratic to your particular sample. What you need to do is, if you noticed it, so you could conduct what's called exploratory research. You could do some exploratory analyses just to see what appears to be connected to what, and then you would use that to go and do another study and actually test that prediction. If I create this theory from this exploratory research, from this data set that I've obtained, I formulate a theory and a prediction, and I collect more data that's not based on the original data, more data, and I see, does that data set support my prediction? What you're not allowed to do is essentially engage in a walk through the garden of forking paths, find something significant, and then pretend that you predicted that all along. As you can imagine, pre-registration really helps with that because it locks you in to one particular analysis. Of course, you could say in your pre-registration, we're going to conduct analyses on the overall result, and then we're also going to look at this selection criteria because it might affect people that don't like coffee differently to people that do like coffee. As long as you pre-register that, that's fine. Now, this idea of the garden of forking paths is actually quite natural. Back in the last American election, when Donald Trump was running against Hillary, the New York Times posted this article, which said, "We gave 4 good pollsters the same raw data. They had 4 different results." And it sounds from this title, maybe you think, well, science, these statisticians don't know anything. Actually, it's just it's a natural consequence of having the garden of forking paths. As you can see here, only one group predicted Donald Trump would win from this polling data. The other 4 groups predicted that Hillary Clinton would win. And even though the numbers don't look that different, they're actually quite substantially different. A difference of Hillary Clinton being up 4 is very different to Hillary Clinton being up 1. Incidentally, the statistics team that predicted Trump winning, it was led by Andrew Gelman. And Andrew Gelman is the person that's really popularized the garden of forking paths in psychology. He's a research methodologist, a statistician, and it's his work that's really made this, that's really highlighted just how problematic taking a stroll down the garden of forking paths is. And of course, he could. Professor Starbucks could have gone another way. Could have looked at different analyses. Could have looked at coffee versus water and done the same test, or excluded different people and dug around. And I hope that what you realize is that pre-registration is one means of locking a researcher into a particular analysis. It prevents people from claiming that they had predicted something in advance that they hadn't predicted, and in fact they just found by exploring their data. And by exploring their data, they may have come across something that's significant in their data set, but that doesn't mean that it actually supports their theory or that the theory actually predicted it. The other questionable research practice that you should know is hypothesizing after results are known. This is Norb Kerr. He wrote his paper in 1998, and when he first wrote it, it didn't get that much attention. It hasn't been until around since 2010. You'll hear me talk about 2010, 2011 a lot. That's when the reproducibility crisis got a lot of attention, and that's when all of these issues and questionable research practices really came under fire. Really, people started to realize how harmful they were for our understanding of psychology and the world around us in general. There's 2 types of HARKing that can be engaged in. One of them is, so if you recall, this is Professor Starbucks, and let's say he's just got his data set and he's realized that his hypothesis wasn't supported. He predicted coffee would improve student performance, and in fact, let's say for this example, coffee reduced student performance. So there's 2 ways that he could engage in HARKing. The first is by forgetting his original hypothesis. And by forget, I mean not reporting, pretending that he hadn't predicted coffee would help versus help improve student performance. The second is by pretending that he had predicted things all along. So maybe he actually, I don't know why Professor Starbucks would want to do this, but maybe he pretends that actually he had always predicted coffee would have a negative impact on student performance. And in that way, what he's doing is he's forgetting his what we call a priori hypothesis, that is, hypothesis that was specified before the study was conducted, a priori, and he is pretending that he had always specified his post hoc hypothesis. Post hoc meaning after the event. So after he's collected data, he's creating a post hoc hypothesis, but he's pretending that it was a priori, and that's what you're not allowed to do. The reason why is because first, you're creating literature bias. You can never falsify either hypothesis. If everyone acted like this, the first hypothesis, nobody would ever know that it was falsified. So had it been supported, he would have published it. So you might get those studies that found evidence by accident, just by chance alone, not because the effect exists, but just because sometimes you're going to get some samples that demonstrate this effect, even though in the actual population it might not, it wouldn't be there. But that will never be falsified if everyone just pretended that they never actually predicted that if it wasn't proven right. And the second thing is, you're also going to get support for the hypothesis that you made up after the fact. Okay, so this word falsification is really important in science. When you conduct a study, it's very important that you can falsify your hypothesis. So usually, if we're predicting a difference, we predicted a difference. A falsification is when there's no difference. Okay. If your study is set up in such a way that you can't falsify your theory, then lots of people would argue you're not really engaging in science. If I gave you a test, all of you a test, that you couldn't fail, a lot of you would think that that's not really a test, is it? If I gave you a test and no matter what answers that all of you gave me, you all gave me different answers and you all received 100%, you might think, well, that's not really a test for the course. And of course it isn't. So we need to make sure that we can falsify our hypotheses. It also gives predictive credit to a hypothesis that did not predict the data ahead of time. So if I were, let's say I am firing my gun, and I show you a video where you see me take out my gun, I fire one shot, and I hit the target. This target is 100 meters away. You think, wow, Neil's really good at firing. If, however, you saw the real video, like a camera behind that camera, and you saw me shoot 1,000 shots and only one of them hit a target, you might think Neil had a lot more chances at hitting a target and he wasn't very good. He only hit 1 out of 1,000 targets. Okay, this is essentially what it is to be pretending that you predict that your theory predicted a result that it did not. You're given credit to a theory for being good and accurate when it's not good and accurate. Even if you do something like drop outcomes, so you drop dependent variables, which is one of the QRPs we discussed last week. You are, let's say you only one of the 3 dependent variables was significant, so you drop the other 2. You're given that theory false credit. It looks like if by only reporting 1 dependent variable, it looks like it was a really good shot. The theory made 1 prediction and it hit it. If in fact you predicted you reported all 3 dependent variables, then your theory looks less good. It had 3 chances and only hit 1. In psychology, this is sometimes referred to as the Texas sharpshooter effect. Yeah, which is and it's nicely summarized by this idea here. Let's say rather than me only showing 1 video, the 1 shot that I hit the target, what if instead I just fired completely randomly at a wall and then went up and drew targets around where I hit? Again, if you turned up after the fact and saw those targets and saw all those arrows in the target, you would think, wow, whoever shot these must have been really good. But in actuality, by HARKing, you're essentially just going up and drawing targets around where the arrows hit. Okay, you've got some noisy data and you're just pretending that you predicted it perfectly. Excuse me. I do just want to point out that there is a difference between exploratory research and confirmatory research. Most of what I'm talking about and most of the research studies that you read use confirmatory research. They test the accuracy of a theory via their predictions. There's a theory. According to this theory, there's certain predictions. We make these predictions in advance. If they're correct, then we say the theory is substantiated or supported. If the theory is not, if the predictions are not correct, then after enough failures to predict an event, we say that the theory is falsified. Now, that's confirmatory research. There's also a lot of room in psychology for exploratory research, essentially meaning that that's when you collect some data, and rather than predict anything, you just explore. It's perfectly fine to do. You go out, you collect data, and you look for relationships, and then you see this correlates strongly with this. There might be something there. Oh, look, it happens for men but not women. I wonder where that might be. That's part of the scientific process. The only thing you're not allowed to do is do exploratory research and pretend that it's confirmatory research. And it's really hard not to do because you can go to this website. I can't find it. I'll post it in the Moodle discussion forum. I didn't put it on the slide for some reason. That shows you all these different variables that correlate, and this is real-world data. So I've got a few examples on the board. I'm just going to focus on one. Did you know, for example, this is true data, the amount of cheese consumption in America correlates with the number of people who died by becoming tangled in their bed sheets. Now you know that's a fact. Now you know that's a true fact in the world. It's very, very easy for someone to generate a hypothesis. It doesn't require any skill or any theoretical rigor. I could say, we know that eating cheese before you go to bed causes nightmares. Therefore, people are eating more cheese, they have nightmares, they become tangled in their bed sheets and they die. Okay. Now that didn't take any research skills or theoretical understanding, and it's very easy to do. Yeah, I'm sure if I gave you the task, you could all come up with a reason. And in fact, if you want to, you can pause the video and try to come up with a theory for each of these. What you're essentially doing is engaging in exploratory research. You found something in the real world and you think maybe there's something to it. And there might be. Now, I'm guessing there's not in each of these cases, but that is the first stage of science. The second stage is to, once we've developed that theory, test it and use it to make predictions. And that's confirmatory research. Remember, this is a great quote from Richard Feynman. He's a physicist. He said, the first principle is that you must not fool yourself, and you are the easiest person to fool. When you engage in this kind of hypothesizing, it's really easy because it seems so convincing, and it's part of research. You know, part of research is to come up with these hypotheses and develop these theories. But the thing is, what we need to do is create a system that, when we are liable to fool ourselves, the system, that is science, makes it harder for us to fool ourselves. One way we can do that is by pre-registration. I just want to briefly cover Brian Wansink. Brian Wansink was a famous psychologist, still is a famous psychologist. I first came across him when I read his book, Mindless Eating. He's found studies such as if you eat your food on a smaller plate, you get full up more. And Brian Wansink had this blog, and in 2016 he published a blog called The Grad Student Who Never Said No. And the purpose of this blog was to say essentially that you should take all the opportunities you get. He gave one student an opportunity to work with him by analyzing some data, and she said no. He gave another student a chance to work with him and analyze some data. She said yes, and she got 5 publications out of it. Now, I put all this up on the screen, and you're welcome to read it. I don't have time to go through all of it now. What you ultimately need to understand is Brian sent this PhD student the data set, and he basically instructed her to p-hack, to come up with as many different ideas and designs as possible, and look at the data and come up with some suggestions and split the participants up in all kinds of ways and look at different dependent variables and come up with stories as to why this difference between men and women might be significant and so on. Okay, now remember, he posted this in 2016, which was just 4 years ago. He posted this on his website as to tell everyone, this is what science is like. This is what research should be like. Now, this actually got quite big news, and BuzzFeed actually ended up getting their hands on some emails, I think through a Freedom of Information request or something like that. And you can see Brian Wansink in his emails to that PhD student telling her to engage in p-hacking. He says, first, look to see if there are weird outliers. So take a look at some outliers, see what happens if you exclude them. Do you get anything interesting? If so, make a note. He also said to essentially go for a walk through the garden of forking path. So he said, look at males, look at females, look at lunch goers, diner goers, people sitting alone, people sitting in groups of 2, people sitting in smaller groups, and so on. What you're witnessing in this email is essentially a walk through the garden of forking paths. And then he said, the third thing that he recommended, and this is just one email, remember, look at a bunch of different DVs. So, you know, maybe we can publish one on pieces of pizza rate. Maybe we can look at how full the plate is. Did they get it? And so on. And remember, the PhD student and Brian got 5 articles out of this one data set. Now, I should just point out, Brian Wansink actually ended up losing his job at Cornell University, which is a really prestigious university. It wasn't just based on that. In fact, my memory from the time of, I was following at the time, and lots of people in the research methodology community, the open science community, were saying, look, give him a chance. He didn't know any better. But he ended up leaving his post at the university. There was an article like this one that found when you looked at 4 of the articles that he and the PhD student published, there were over 150 inconsistencies that couldn't be explained across them. So, I mean, let's just say, off the top of my head, maybe one of them said that they recruited 200 participants for the study, and one of them said they recruited 150. Which one was it? Yeah, that would be considered an inconsistency. There were a lot more inconsistencies than that, more important inconsistencies than that. And that he was also caught self-plagiarizing, which is another issue because it also biases the literature. If I have so in this example, 2 articles that he published appeared to be really overlapping, and ultimately that's not fair. If you have 2 studies, the person who did this, you see down in the bottom of the slide there is a link to this blog post, and he said that they're essentially the same study. So again, you're biasing the literature. You've done one study, and you're putting work out there that will make people think there's 2 different studies. So he ended up losing his job, but the reason I present Wansink, this example to you, is because this was in 2016. So one of the students in my lab this week said, if you're not allowed to do QRPs, why are people doing QRPs? And the answer is, don't forget, it's only been about 10 years since we've really known the impact of these QRPs, to the point where Brian Wansink, who had millions of pounds worth of funding, dollars worth, he was some kind of advisor to the White House at one point in terms of nutrition and dietary guidelines. And he went and posted a blog post describing basically a process of conducting questionable research practices and didn't know any better. Okay, so these are very new findings. That said, remember that now we do know this. If you were to knowingly engage in these acts, I think today the word questionable, it wouldn't really be considered questionable. It would, if you were to just walk through the garden of forking paths, be considered more fraudulent or just flat-out fabrication to misrepresent the process that you engaged in order to get those results. Okay, so what is pre-registration? It's when researchers describe the hypotheses, methods, and analyses before a piece of research is conducted in a way that can be externally verified. Okay, that's ultimately what pre-registration is. It's that simple. Writing down what you're going to do, getting it time-stamped, and you have to be able to verify externally. And we've already seen that one of the reasons why we do this is to prevent questionable research practices. And today we're going to be talking about 2 types of pre-registration, unreviewed and reviewed. This should look familiar to you. It's the open science process, or the traditional publication model. And the easiest way to incorporate pre-registration is simple. Like we saw last week, you simply complete a pre-registration form after planning the study, but prior to conducting the study. This type of form this type of pre-registration is the most common by far. And if you look at this article, there's a nice graph here that this article produced, which is, if you look at the black line, on the x-axis at the bottom is the year, and the black line represents the number of pre-registrations saved on the Open Science Framework. And as you can see on the left side of the graph, where there's over 18,000 in just 6 years of this graph, there's been 18,000 pre-registrations created, which just goes to show how quickly pre-registration is becoming a really important part of science. Now, I won't spend too long. Essentially, when you can go to a website aspredicted.org, and it asks you to complete a series of questions. For example, have you collected data yet? What are your hypotheses? What are your dependent variables? What conditions have you included? What are your analyses? What are you going to be doing in order to test your hypotheses? What outliers and exclusions have you decided upon before collecting data? What sample size are you going to recruit? Because remember, you're not allowed to recruit participants, test for the results, and recruit more. Test the results and then recruit further participants. And any other. Okay, so this is what the pre-registration format as predicted looks like, and most pre-registrations tend to follow this kind of thing. You can see how if Brian Wansink had been requested to complete one of these and submit one of these for each of his studies, he would have had a hard time, because his original study was, in his own words, a fail. He would have had to admit that all of the analyses he did subsequently were just exploratory, and it's unlikely, in my opinion, they would have got published in the paper, in the journals they got published in. Yeah, this is just to demonstrate that all of these things that he was requiring of his PhD student wouldn't have been possible. There is, and I should say that one of the benefits of this, very quick and easy. Yeah, you don't have to change your whole research process. You can do it. You can just complete a form prior to collecting data, and you're ready to go. Where's my phone? Okay, 30 minutes. Okay, problem with this, unfortunately, is that it is possible to game the system. So it is possible that someone, I'm not saying programmatic, but somebody could complete 5 different versions of a form and just use the one that they end up doing. So it's certainly not foolproof. It's certainly possible to game the system, or you could always, collect data and then do a pre-registration form and claim that you did it before, or that you collected the data after. That's harder to do because usually data is time-stamped, but not always. There's lots of data that wouldn't be time-stamped that you could game the system. What's harder to game, but also takes a little bit more work, is the registered report system. So here again we have the traditional scientific process, and the registered report basically just reorganizes it a little bit. So it puts, when you want to write a registered report, you plan the study, you actually write down the introduction and the methodology, and then you submit that to a journal. You go through the peer review process, and once it's accepted, only then do you conduct the study. So this has benefits over the other one, over the previous version, the unreviewed version, in that you actually have a paper, a guaranteed publication, once you've collected your data, regardless of which way it goes, regardless of the results. The first journal that started to offer registered reports was Cortex, which is a really big journal in psychology, and its editor is Chris Chambers. And Chris outlines the process where authors submit what's called a stage 1 manuscript, which basically is an introduction and proposed methods and analyses, and where possible, if you had any kind of exploratory data, you could include that and explain, based on this data, you're testing these hypotheses. And you submit it for stage 1 peer review, at which point reviewers will ask questions like, are the hypotheses well-founded? Are the methods proposed feasible? Are they sufficiently detailed? And so on. And if the reviewers are happy with this, they will be they approve the manuscript at that point. So the author's told, we will publish this if you do the study as you've described it. The authors go out, and by the way, this is essentially what your assignment is. You guys are submitting a stage 1 registered report. The only difference is you're doing a registered replication report, which is basically replicating a study, but everything else is identical to what we just saw. Then the authors would do the research. They resubmit what's called a stage 2 manuscript. This it's basically the introduction of methods which haven't changed. It has the results and discussion and the data, and then they have to submit the data as well. This goes through peer review again, but it's a lot simpler and a lot quicker because most of the hard work's already been done. And then if the editors and the reviewers are happy, it gets published. I actually have an example of, I've actually just going through this process now. Back in 2018, I had stage 1 acceptance at Cortex, and my collaborators and I just submitted the stage 2, which we hope will be the final version. And it's been really helpful. The number one thing I would say about registered reports is, for me as a researcher, it was getting feedback at stage 1 before collecting data. If you think about the way we do science normally, usually we conduct the study and then try and convince people they should publish it, and they come back to it and tell us that there's all kinds of mistakes in it. It makes so much more sense to do it this way around, where you get feedback before you started conducting a study. I think it was 4 experts contacting us and reviewing our paper and telling us ways we can make the study better. I should just flag that if any of you want to read more on this whole topic of open science and questionable research practices, Chris Chambers has an excellent book called The 7 Deadly Sins of Psychology that I highly recommend. And he also wrote this article, which I linked to at the bottom of the slide, where he shows again the explosion in the use of registered reports Bearing in mind that his journal was the first journal in 2013 to offer them in psychology, you can see now we've had over 200 journals now permit registered reports, and he just had the publication of the 100th registered report published. So, to make sure you're familiar with the benefits of questionable research, not questionable research practices, make sure you're familiar with the benefits of registered report and also the limitations, and I summarize them here. Firstly, of course, they limit researcher degrees of freedom. That's not necessarily the same thing as limiting questionable research practices. I have degrees of freedom, I have flexibility, even without knowing I have it. Even if I'm just accidentally walking through the garden of forking paths, but I thought I was, and I can't necessarily consciously state that I'm doing so. It just limits my flexibility. Even if there's no malicious intent, there is flexibility. It enhances transparency of the research process, which is always a good thing. The more transparent, the better. It requires authors to think ahead. You know, you'll be told time and time again when you do your final year project dissertation, make sure that you think about how you're going to analyze your data, because if you collect data and you can't analyze it, it's worthless. So and pre-registration makes researchers engage at a really deep level before they've recruited any actual data. It allows researchers to prove their research is credible. So if I know that I've not done anything wrong, or I know I've conducted solid research, I can actually pre-register ahead and show people that I stuck to the plan. As I mentioned, registered reports, that's the reviewed version, allows peer review before data collection. It also allows guarantees of publication before I've even started recruitment, which is one of those things I discussed earlier in terms of aligning what's good for the researcher with what's good for science. This registered reports model of publishing aligns them both very well together. I'm getting publications, science is getting the results regardless of what they say. Okay, and it improves the credibility of research. Now, don't just take my word for it, of course. There is evidence, and it's still early, but there's early evidence to suggest that this is the case. For example, Kaplan and Irvin looked at studies conducted and submitted to the National Heart, Lung and Blood Institute. Now, in the year 2000, the NHLBI required researchers to start pre-registering their studies. And Kaplan and Irvin were wondering, did this make an impact on the results that studies reported after 2000 compared to before? Now, if you look at this graph, on the bottom, on the x-axis, is the publication year, and the green dots are the non-significant results. In other words, they're the studies that found no difference. The circles with the cross in are the studies that reported a beneficial effect of whatever the intervention is. So it could be, for example, a pill on blood pressure. And the circles with the cross in say, yep, there's a positive effect of this drug that we've been investigating. Now, if you look at the straight line at the year 2000, that's when pre-registration was introduced to the NHLBI. And what you see is, before that line, I think it's nearly 60% of studies reported finding some benefit. That reduced to 8% of studies afterwards. So you've gone from nearly 60% to not even 10% of studies reporting a benefit. And most studies report a non-significant effect. Okay. Now, Daniel Akins is somebody that I encourage you to follow on Twitter. And I saw this nice tweet from him a while ago. He said, people sometimes wonder if pre-registration is worth the effort. I showed them Kaplan and Irvin's 2015 findings on the likelihood of null effects before and after pre-reg became required in medicine, and asked if they want a drug discovered in 1998 or 2002. Pre-registration makes it difficult for people to find significant results when none exists. Okay. Lakins has also done some research where he looked at the findings of registered reports and compared them to the findings of standard reports. So, for example, first he looked at just original studies. So these are studies that are conducting completely novel research. And he found 148 standard studies that don't have pre-registration. And he looked at the 30 registered reports. So this is the stage 1, stage 2 kind of review version. And he found 50% of the registered reports found support for the hypotheses versus 95%. Now, if you remember back to last week, 95% is about how many studies in the literature claim to support their hypotheses or have found support for hypotheses. So that's very much in line with what previous studies have found. This drops to 50%. Okay, so that suggests that there's about 45% of studies out there that wouldn't have been significant if the authors couldn't have engaged in questionable research practices. Now, Lakens in this paper and his team also looked at replication studies, and the reason they separated them out was because the reason why somebody might do a replication is because they're skeptical of the result. So if a result comes out and it's not very believable, maybe they do a replication to prove that actually, no, we shouldn't be believing this first paper, here's a registered report, and it's non-significant. And what they found was, again, similar numbers, 100% of the standard reports that weren't pre-registered found support for the replication study versus 40% found support for the, only 40% found support for hypotheses of studies that replicated in the registered report studies. Okay, so again, it's a little bit less, 40% versus 50%, and that might be because people replicate studies that they don't expect to replicate really anyway. They're already dubious of. But again, these numbers suggest that pre-registration is helping to clean up science a little bit. It's helping to make our results actually meaningful. That when there's no effect going on, we're reporting that there's no effect. We're not just digging around and going for a walk through the garden of forking paths. Okay, just as important to know the benefits of pre-registration, it's also important to know the limitations. The first three I've put question marks next to, and I'm presenting them together because you'll commonly hear these discussed as limitations, but I don't necessarily think they are. For example, that they limit creativity. I thought this before I actually started pre-registering, and I don't see why this is actually, I don't consider this to be a valid criticism or limitation, because when you do a pre-registration, you can then do the study, and let's say for whatever reason you want to, you can have an exploration. You can again look into your data, look for ideas, generate theories and hypotheses for future studies to test. But you just have to make sure you specify that they are exploratory analyses, that you didn't predict them in advance, so you're not given a theory credit for having predicted them. They can require large output. This is for specifically reviewed pre-registration. They can require large output of effort with no publication. So let's say I submit to Cortex, go through all this work of writing an introduction to methodology, and they say no. Again, I don't consider this to be a very good limitation or a very valid limitation, because I've still got that work done. I can still do a normal an unreviewed pre-registration and then submit it as normal anyway. So just because maybe I don't get accepted for a registered report, I can still do the study and publish it the traditional way with an unreviewed pre-registration form. The last one is that it could create a bottleneck of research. This is the idea that if you get a certain type of people reviewing papers, registered reports won't be allowed to get done, because if you're trying to replicate my study and I don't want you to replicate it for whatever reason, I can just say no, I don't think you should replicate it. And I might be a reviewer on your study because I'm an expert in the field. You're replicating my study. Again, I don't think this is valid. I think reviewers are held accountable too, and the editor will hold the reviewer accountable. They have to be justified in saying what the reasons are. But also, if you couldn't get this accepted, again, you could just go conduct the study anyway and use an unreviewed pre-registration. The following limitations, however, I do consider more valid. For example, is anyone checking quality or adherence to the pre-registration? I know that I've submitted a pre-registration before, and I wrote in the paper that the reviewers are welcome to check my pre-registration, and then I realized that I hadn't actually made the project public, so the reviewers hadn't been able to see the pre-registration. So obviously they didn't bother reading it or checking it, they were just taking my word for it. And there is some research to suggest that this is the case. So for example, Daniel Lakens again has a preprint that you can read, the link is at the bottom of the slide, where he looked at 62 registered reports, and he basically found there was some variation in terms of how many papers had uploaded their data sets, how many uploaded their analysis scripts. You are all the first cohort to be learning to use R. And what that lets you do is you can actually upload your analysis script, so everyone should, in theory, if you give them your data, be able to absolutely reproduce your results. And in fact, when they try to reproduce the results, they can only do so in 58% of the registered the registered reports. So just because people are registering doesn't mean that they're necessarily following the rules of the registered report format, which means make your data set available, make sure your results are reproducible. It is possible to gain pre-registration. As I said earlier, it's easier to do so if you're using unreviewed pre-registration. There's a couple ways you can do it. You can create multiple pre-registrations and just submit the one that you actually ended up using. Or you could, I don't know why you would do that, because it's not, you could just pre-register all of those analyses in your one pre-registration. Just be open with the fact that you did all 4 analyses and that you reported the one that worked. But there might be some dubious reasons why you wouldn't want to do that. It's also possible to collect data first and then you do the study. Now, you could do this with registered reports. So you collect data first and then you do the pre-reg. You could do this with registered reports, so with the reviewed version of pre-registration. However, most journals request or require that you have both a time-stamped pre-reg and a time-stamped data set. So it's not like, for example, when I collect data online, I use Qualtrics, and Qualtrics always includes the date that the data was collected. So I always leave that in just so people can see when the data was collected. This is a really important one. There's no guarantee that the study is any good just because you have pre-registered. And it can be, you can get lazy. You do think, I can think that, this study is pre-registered, therefore it must be brilliant. But there are plenty of examples now where the pre-registrations haven't been great. So for example, there's been research to show that when people pre-register, they usually say, here's my pre-registration, I've uploaded it to OSF. One team of researchers, who I can't find now, but I will be sure to add to the slides, they demonstrated that they looked at all the papers that had pre-registered in a journal called Psychological Science between 2015 and 2017, and they found that in at least every single paper that claimed to have pre-registered had at least one major deviation from their pre-registration. That's fine, but they hadn't specified it. So it was an unspecified deviation from the pre-registration. So they're taking the credit for having pre-registered. They're getting a theory all that credibility, but they haven't actually pre-registered. And there's also so there is that issue. Okay, there's no guarantee that a study is any good whatsoever. And that's actually separate from the fact that the pre-registration might not be any good. The study itself, if you and I came up with a study where we look at whether or not maybe we investigate that one of the graphs that I showed earlier about eating cheese and having nightmares, and we find this effect, so we come up with a study to see whether or not eating cheese predicts nightmares that I had, but we don't really give it much thought. We don't think about, well, what happens if people don't have nightmares? We just include everyone, even if they didn't have nightmares, and so on. Just because you've come up with the study and you've pre-registered it doesn't mean that the study itself is good. You still have all the issues that Sally covered in the first 4 weeks of term, talking about reliability and validity. Is the operationalization appropriate? Have they adopted the right kind of design in terms of within or between, and so on. Okay, and that brings us to the end of the lecture. And what time are we at now? Nearly 50 minutes, perfect. Just remember, these are the key learning outcomes, okay? You need to make sure you're familiar with the Garden of Fork and Paths and that you can discuss what HARKing is. Again, it's one thing to remember a definition, and always remember definitions. If I were to meet you and ask you what HARKing is, you should be able to tell me in a succinct manner what HARKing is. But also reflect on it, reflect it back into what it means for our understanding of reality. How does it have a negative impact on the scientific literature? Make sure you can again provide a definition of what pre-registration is, and also discuss the different types, unreviewed versus reviewed. And remember, you guys are essentially submitting a stage 1 registered replication report for your assignment. And then of course you should be able to specify what the benefits are of pre-registration, both the kind of theoretical as well as what the empirical evidence is for those claims. And it is starting, especially I found a lot in PsycArchive. If you go to that preprint website that I've linked to a few times in this talk, you'll find a few studies up there that are looking at the impact of pre-registration and how it's affecting the credibility of our results. And I've discussed a few of those studies here. And of course, make sure you're familiar with the limitations. Now, some of the limitations that were widely discussed a few years ago, as I say, about creativity, I think they've mostly been sorted out. Most people don't. Most people now know that they're not really an issue. That if you want to be creative and start kind of doing exploratory research, you just have to state that you're deviating from your pre-registration, or you can list them in the unpre-registered analysis section. But there are some limitations that you should be aware of. Make sure you know what they are. The content of this week's lab will go over them. The worksheet this week just asks you to think about what the strengths and limitations are of the different types of methods. Hopefully, I hope you found this lecture interesting. I hope you understand just how powerful of a tool pre-registration is in helping to improve the credibility of our research. And in the meantime, I have nothing more to say other than to hope you have a great rest of your day, and I will see you in the labs. Thank you very much.